Hello and welcome back to this video. So in this episode we're going to continue our lessons on basic introduction to Numpy arrays, and we're going to continue from where we left off. So in the earlier demonstrations, as you can see from here, you can see that in creating the NP array, I passed in the list of lists directly into the constructor of the NP array object, okay, or the NP array function call. But one thing I want you to know is you can also create a normal Python list of lists and pass that into the NP array function and then get the corresponding matrix created for you. So let's say I'm going to create a matrix, but then I'm going to start by having let's say numbers, or I'll say entries is equal to, and then I'm going to create a list of lists. This right here is a normal Python list, okay? So I'm going to do 1 2 3, and then there's going to be another list here, 4 5 6, okay? If we check the type of entries, this is a plain old Python list, and I'm going to show you how you can convert this into a NumPy array or matrix. So I'm going to say A is equal to np.array, and then I'm going to pass in entries, okay? Now if you print A, you can see that A is now a NumPy array. How do you know that? You can do type of A, and you see that the type is now NDArray, okay? Now by default, NumPy infers the data type of the multi-dimensional array based on the values that you put in there. So if you check a.type, a.dtype, you can see that by default it assumed that they are integers, because of course what the values that we placed in the list were all integers. So by default it assumed that we are trying to create an array of integers, or a multi-dimensional array of integers. Now one way we can convert a matrix from one type to another is to use a function called asType, okay? So if I want to convert A into a matrix of floating point numbers, or I want to convert it into an array of floating point numbers, what I can do is I'll say B is equal to a.asType, and then I specify the type, which is np.float32. So if I do this, and then I can print B, but it's not necessary here. And as you can see, the type here is float32, and you can also see that each of the entries has been appended with a 0.0 to indicate that they are all floating point numbers. So one way you can convert an array of one type to another is to use the function asType, okay? Another way you can do is to do it on the fly. So I can say C, let's create a vector here. So I'll say C, and by the way, you can see that I'm using capital letters to represent matrices, and then small letters to represent vectors. It is only conventional in mathematics. It is not required in Python, but I'm just doing that because mathematically that is how we distinguish between vectors and matrices. So I'm going to create np.array, and I'm going to put in the numbers 5 to 1. And on the fly, I'm going to say dtype is equal to np.float32. And what this means is that I am creating an array that has 5.0, 3.0, and then 1.0. And the way NumPy knows this is because I specified the dtype to be np.float32. You can go to np.float64, and we have int 64, int 32, int 16, and I think int 8. You can find all the details on the NumPy official documentation website. So if I check c.dtype, you can see that now C has the type of float32, and so that is how you can create an array and then also specify the data type on the fly, okay? So there is one other thing that you can do if you want to check how much space each entry in the array is taking, okay? So for example, with our array A here. Let me print it again so you see what's in there. So array A is basically an array of integers, and the way I know that is when I do a.dtype, I can see that each one of them is an int64 value. Okay, now if I want to see how much space in memory each of the entries is taking, then there's an attribute. I can just say a.item size. And once I do this, you can see that it is returning 8. What it means is that each value in the array is taking up 8 bytes of memory. And I mean, this is quite obvious because we are representing integers here. And then it is telling me that because I'm using int64, it is taking 8 bytes of memory to represent each entry in the array. Okay, so that is how you check how much space each entry in the array is taking. And in case you're wondering, how do I know how much space the entire array is taking? Hold on, I'm going to show you one more attribute that is going to help you to know how to do this. Okay, so let me print the matrix A again. You can see that the matrix A has 6 elements from 1 to 6. It doesn't always have to follow like 1, 2, 3, 4, 5. You can store anything in there. It just happens that in my examples I like to use 1, 2, 3, 4, 5, 6, but it contains 6 elements. And how do I know that? I know that by typing a.size. Okay, so the size attribute is always going to tell you the number of entries in your NDArray. Okay, so now you know two things. You know item size gives you how much space each entry is taking in memory in bytes. Okay, and then you also have the size attribute that tells you how many entries you have in the array. So if I want to know in total how much my matrix A is taking up in memory, all I need to do is to say a.item size multiplied by a.size. Okay, and so this is telling me that the array or the matrix A is occupying 48 bytes of memory. This is basically how you check how much size your array is taking in your memory. And the unit of measurement here, of course, is byte. Okay, there are two more attributes that I want to share with you in this video before we move on to the next video. And the next attribute I'm going to talk about is ndim. The ndim is basically the number of dimensions of an array. Okay, and it's also known as the rank. And what the ndim tells you is it is telling you how many indices you need to specify to access an entry in the array. And by the way, I have not shown you how to access individual elements or even subgroups of elements in an array, so don't bother about it yet. But I want you to know that if you check the ndim or the n dimension of an array, basically you're also checking the rank of the array, and it tells you how many indices you need to specify to access a single element or even groups of elements within the array. So we had a vector A. Okay, we didn't have a vector A. What did we have? I created some vectors here. Okay, we have a vector C. Sorry. So we have a vector C which has 3 elements, and then I can see c.ndim, and let's see what that returns. It returns 1. What it means is this is basically a one-dimensional array, which is also known as a vector. And this vector could be a row vector or a column vector. I will also explain that in subsequent videos. But what the ndim 1 means is that to access any element of this array, you only have to give 1 index. So for example, in C, the first element is 5, the second is 3, the third is 1. And like all arrays in Python or list in Python, you index them starting from 0. So if I want to access this value here, it is index 0, 1, and then this is 2. So if I do C, and then I'm going ahead of myself here, but it's okay. So if I access the element at index 1, is going to give me 3. And the reason why we specified only 1 index here is because the ndim of the array is 1. If I access element 2 is going to give me 1.0 because the thing at the index 2, because you start counting from 0, is 1 over here. That is the value that is stored over there. And as you have seen already, if I check for the ending of a matrix, I am expecting the value 2, because to address each individual element in a matrix, you need the row index and then the column index to be able to target individual entries in a matrix. And so the last attribute I want to share with you is the shape, which you have seen before. So if I do c.shape, you can see that the shape is 3 by nothing. What it basically means is that it is a single dimensional array or a vector that has 3 elements. But if I check a.shape, you can see that A has 2 rows and then 3 columns. Always remember the order. For matrices, the number of rows come first, and then the number of columns is the next figure to follow. Now, you may be wondering, is this all we can do with NumPy arrays? No, we can represent 3-dimensional vectors, 4-dimensional, and in fact n-dimensional. That is why the data type is called NDArray. So it doesn't have a limit to the number of dimensions, just that we humans are limited to 3D, and above that we can't really imagine things very well. We can't visualize things, but then the computer doesn't have any issue representing n-dimensional arrays with very huge dimensions. So basically, these are the few attributes of an ND array that you need to know of. Thank you very much for watching, and I'll see you in the next video.